In this video, we are going to solve cubic equations with the help of the rational root theorem and synthetic division. So here we have a cubic equation set equal to 0, and our job is to find the roots of that equation. Now, some other ways of asking that same question are to find the zeros, and we can also just find the solutions, all basically the same thing. So roots, zeros, and solutions. All right, the first thing we should check real quick is to see if there is a common factor that we can factor out of all four terms. In this case, there is not. But fortunately, we have the rational root theorem, which gives us a way to find factors. So let's give that a try. Now, in the rational root theorem, we're going to take the factors of the constant term divided by the factors of the leading coefficient. So in this case, that would be 1. So I'm going to make a fraction, and in the numerator will be the factors of 3. We don't need to worry about the sign when doing the rational root theorem. And then in the denominator, we will have factors of 1. All right, so the factors of 3 are positive and negative 1, and positive and negative 3. The factors of the number 1 are just positive and negative 1. All right, let's simplify this a little bit. So we have positive and negative 1 over positive and negative 1. Let's see, that's 1 divided by 1. So that's just 1, or positive and negative 1. And then we have 3 over 1. Well, that's just 3. So here we have 4 possible rational roots. Positive 1, negative 1, positive 3, and negative 3. Let's start at the beginning here with positive 1, and we will use synthetic division to see if one of these 4 numbers is a root of this polynomial. All right, with synthetic division, we're using the coefficients of each term and the constant term. So that'll be 1, 3, negative 1, and negative 3. We have this special little synthetic division bar. And let's start with our root, or 0 of 1. So we bring down our 1 and multiply. Then we add. And we multiply. And we add. And we multiply. And then we add. And this last number here is our remainder. We get a remainder of 0. That's good. That means that we found a 0, or a root, of this polynomial. Now we found a 0 of x equals 1. Let's go ahead and convert that into factored form. So I'm going to subtract 1 from both sides. And a root of x equals 1 corresponds to a factor of x minus 1. All right, so we're going to rewrite this in factored form. So our first factor is x minus 1. And then what's left is x squared plus 4x plus 3. Now we have a binomial times a trinomial. Let's see if we can factor this trinomial some more. So I want 2 numbers that multiply to make 3, that add up to 4. And sure enough, 3 times 1 equals 3, and 3 plus 1 equals 4. So we have factors of x minus 1, x plus 3, and x plus 1. So we have something times something times something equals 0. Well, in order for that to be true, one of these 3 binomials must equal 0. So if it's the first one, then x minus 1 would equal 0, which would mean x equals 1, because 1 minus 1 is 0. If it's the second thing, x must equal negative 3. It's negative 3 plus 3 is 0. And if it's the third binomial that equals 0, then x must equal negative 1. So we have 3 solutions for x. And these are also the roots, or the zeros, of this equation. So this was an example of a cubic equation that was factorable into three binomials. This time our equation is written as a function. So if f of x equals 3x cubed plus 5x squared minus 20x minus 4. Let's find the zeros, or in other words, we're finding the roots, or we're finding the solutions when this function equals 0. So I'm going to write this polynomial equal to 0 since we're finding the zeros. First thing, we should look to see if there are any common factors that we can factor out of each term, and there are not. So the next thing we should try is to use the rational root theorem to get a list of all the possible rational roots and to see if we can find a factor that way. So to use the rational root theorem, we're going to put the factors of 4 in the numerator and the factors of 3 in the denominator. Let's see the factors of 4. That would be positive and negative 1, positive and negative 2, positive and negative 4. The factors of 3 are just 1 and 3. So we have positive, negative 1, positive, and negative 3. All right, simplifying this some more, we have 1 over 1 and 1 over 3. Then we have 2 over 1 and 2 over 3. And then we have 4 over 1 and 4 over 3. Let's simplify this a little bit more because we have some 1's in the denominator that we can get rid of. Well, let's go through this list. We will focus on the easy possible roots here, which would be positive and negative 1, positive and negative 2, and positive and negative 4. We'll start at the beginning and check with the 1's. So I'm going to use synthetic division now to see if any of these are indeed roots. So I'll be using 3, 5, negative 20, and negative 4 while I do synthetic division. And I'm going to check positive 1 first. So I bring down my 3 and multiply, add, and I multiply again, add, and I multiply again, and I do not get a remainder of 0, so 1 is not a root. Let's try negative 1. Same thing, 3, 5, negative 20, and negative 4. Once again, I do not get a remainder of 0, so negative 1 is not a root either. Let's keep going. We'll skip these fractions here, and we'll try positive 2. Success! We got a remainder of 0, so 2 is a root of this equation. So x equals 2 is a 0 or a root. Let's go ahead and convert that into factored form. That would be x minus 2. So now let's go ahead and write this using x minus 2 as a factor. So I have x minus 2 times, well, that would be 3x squared plus 11x plus 2. Still equals 0. So I rewrote this cubic polynomial as the product of a binomial and a trinomial. Now we could try to factor this trinomial here, but at this point it might just be easier to go to the quadratic formula, because here we still have something times something equals 0. Well, if this first thing is 0, then x must equal 2. And now we're looking to see for what x's make this trinomial 0. That's a good job for the quadratic formula. All right, quadratic formula says that x equals negative b plus or minus the square root of b squared minus 4ac, all of that over 2 times a. So we're focusing on this trinomial here. So a is 3, b is 11, and c is 2. So I have x equals negative b plus or minus the square root of b squared minus 4 times a times c. All that over 2 times a. Let's simplify underneath the square root sign. So I have 11 squared, and 4 times 3 is 12, times 2 is 24, so minus 24. And all that over 2 times 3, which is 6. We'll continue simplifying underneath the square root sign. So we have negative 11 plus or minus the square root of, that looks like 97. All of that over 6. Now we should always check to see if we can simplify our square roots. In this case, 97 is a prime number, so it is already simplified. And the quadratic formula has told us 2 more roots, or zeros, or solutions. So our solutions are x equals 2, and then we have x equals negative 11 plus the square root of 97 over 6. And here's our third root, negative 11 minus the square root of 97 over 6. So we use the rational root theorem to find potential or possible roots. We use synthetic division then to find one that was actually a root. That allowed us to partially factor the cubic polynomial. And from there we used the quadratic formula to figure out the rest of the zeros. In this last example, we're going to find the zeros of y equals x cubed plus 7x squared plus 17x plus 15. And remember, that's the same thing as roots or solutions when the equation equals 0. So let's go ahead and set that equal to 0 right now. All right, we take a quick glance and notice that we cannot factor out a common factor. So we'll move on to using the rational root theorem to find a root, hopefully find a root. All right, we're going to take the factors of 15 in the numerator over the factors of 1 in the denominator. All right, the factors of 1 are just positive and negative 1, so we can ignore the denominator here. So the factors of 15 are positive and negative 1, positive and negative 3, positive and negative 5, and positive and negative 15. Let's use synthetic division to hopefully find a rational root. All right, as we set up our synthetic division, we'll be using 1, 7, 17, and 15. And we'll start with a root of 1. We do not have a remainder of 0, so let's keep looking. We'll try negative 1. We have a remainder of 4, so negative 1 is not a root. Let's keep trying with 3. Definitely not a remainder of 0 on that one. Let's try negative 3. Success. Remainder of 0. We found a root. So negative 3 is a root of this equation. When we have a root of negative 3, the matching factor is x plus 3. So let's rewrite this in partially factored form. So we have x plus 3 times x squared plus 4x plus 5. And all of that still equals 0. So we rewrote this cubic polynomial as the product of this binomial and this trinomial. At first glance, this trinomial looks factorable, but when we think about it some more, it is not. So let's go straight to the quadratic formula to see if we can find the rest of our solutions. So we already know one solution. We know that x equals -3 is a root or 0 or solution. Let's try and find some more. Right, so in this trinomial, we have an a of 1, a b of 4, and a c of 5. So x equals the opposite of b plus or minus the square root of b squared minus 4, always 4, times a times c. All that over 2 times a. Let's continue by simplifying underneath the square root sign. So that's 4 squared is 16 minus 20. 4 times 1 times 5. All of that over 2. Let's continue simplifying underneath the square root sign. So we have -4 plus or minus the square root of -4. All of that over 2. Now, when we're using the real numbers, we do not have any square roots of negative numbers. But with imaginary numbers, we can use the imaginary number I, because that equals the square root of -1, and that allows us to continue. So let's rewrite that as -4 plus or minus the square root of -1 times the square root of 4. And all of that is over 2. The square root of -1 equals I, and the square root of 4 equals a plain old 2. Now, before we finalize our answer, we notice that we can divide all 3 of these terms by 2. So let's go ahead and do that. Let's see, now the denominator, 2 divided by 2 is 1. We end up with a 1 in the denominator, which means we can get rid of the denominator. So we have -4 divided by 2 is -2, plus or minus, let's see, 2 divided by 2 is 1, so that's just I. All right, so we just found 2 more roots or zeros or solutions. So we also have x equals -2 plus I and -2 minus I. In this video, we solved cubic equations using the rational root theorem and synthetic division. Hopefully these examples have been helpful. I'm Mr. Ela, signing off.